Hello, virtual students. Okay, so everybody, we're looking at page 671. If you did not watch the video that I had posted, last Friday, I believe, Thursday. And I know sometimes it's hard to watch those because you don't have your headphones. But basically, here's some of the info that we talked about in that video. The geometric mean is not an arithmetic mean. Arithmetic mean is an average. Geometric mean is basically the square root of the product between two numbers. The square root of the product of two numbers. That's the geometric mean. And so in our triangle similarities, we can set up that h is the geometric mean between the parts of the hypotenuse. A is the geometric mean between the adjacent side and the entire one, x and c. And B is the geometric mean between y and c. We use that on the homework, all three of those. So if I look at this, I have x is the geometric mean between 9 and 20, which means 9 times 20 is 180 square root. Then what's the square root of 180? All right, so let's talk about that. If I have the number 180 and I have the square root, how can I find that? Well, it's not a perfect square. What is it? What's a perfect square? You guys know what a perfect square is? Yeah, so it's not a decimal. So here with me, let's do this little exercise together, all right? So say it out loud, kind of like a chorus here, okay? Maggie, you're welcome to sing it if you'd like. I don't mind. 2 squared. Out loud. 2 squared. No. What is 2 squared? Ooh, I'm not a very good director. That's my bad. All right, 2 squared is equal to, okay, 3 squared. Squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. About everybody is good on 1 through 10. Okay? I'd recommend that you also become equally as good on 11 through 21. Let's go through them together. 11 squared. 12 squared. 13 squared. 14 squared. Good. A good way to remember that. A good way to remember that is switch the places of the last 2 digits. If you remember 13 squared, 196.
Honestly, you had a number between like 200 and 0.
15 squared. 225. 16 squared. 256. 17 squared. 289. 18 squared. 324. 19 squared. 361. 20 squared. So, I know we all know 1 through 10, but it would be good to know 11 through 20 as well. Now, it's not required. We're not going to quiz you over it. But it does help when we're trying to simplify some radicals. For instance, take a look at the square root of 180. The square root of 180 is not a perfect square. I can go through all these numbers. It's somewhere between 13 and 14. Okay? However, the factors of 180, there is a perfect square. Okay? And (36 times 5). And the reason why I use 36 is because it's a perfect square. Does that make sense? And so I could rewrite the square root of 180 just like the old-time factor trees in 5th grade. Square root of 180 is equivalent to the square root of 36 times the square root of 5. What's the square root of 36? We already talked about. 6. Does it need the radical sign then? No. And so the square root of 180 in simplified form, which is called radical form, is 6 radical 5. Now, I'm not going to require you to know how to simplify a radical. I've already said that. Meaning, if you put the square root of 180 into the calculator and you have a decimal that comes up, that's acceptable for an answer. Okay? But it is a good thing to think through. As you get further along in math, there will be things such as scientific notation that you have to think about factorization and how numbers work, basically. Okay? Yes. Okay, square root of 180. Any questions on radical form and simplifying radicals? All right, good. Let's you're already turned there in your book. Let's take a look at a few problems from your homework. The first one I want to look at is number 11. So looking at page 471, 671, 671, number 11. Let me recreate the picture, the diagram. We know that that's a right triangle. The Pythagorean theorem is talked about in this section. We know that the altitude is drawn in. There's the altitude. Perpendicular to the opposite side. So 30 and 40. And then we have x is the geometric mean. X is also the altitude. We have y. And we have z. Okay, let's start with x. X is the geometric mean. This is from our notes and stuff that we talked about last week. X is the geometric mean, meaning it's a blank proportion. And I put the geometric mean there and there. X and X. Now, in this case, it's the geometric mean between the parts of the hypotenuse. So 30 would go there, and 40 would go there. Okay, so now to solve the proportion, nothing changes as we've done it in the past. X squared is equal to 1200, 30 times 40. Now I'm going to simplify both sides. So then x is equal to, well, that's the square root of 400 times the square root of 3. 400 is a perfect square because it's 20 times 20. And so we end up with radical 3 times 20. Again, if you gave a decimal, that's acceptable. That is in radical form. Okay? All right, let's do another one. But this time, let's solve for y. All right, so now y is the geometric mean between the adjacent side, which is 30, and the entire hypotenuse, which is 30 plus 40, which is 70. That's always the case. So y times y is y squared, and that's equal to 2100. Okay? We take the square root, and we end up with y. And factoring out 2100, let's see. Well, I know that I could go 100 times 21. 100 is a perfect square. And so I end up with radical 21 times 10 is equal to y. Questions? Are we getting the hang of this? All right, let's do z then.
I have a question.
Yes.
So could you do like another square root though? So say for the first one, like 1200. Could you do like I don't even know. Let's see, the square root of 600. It's not perfect.
That's the key, Bo.
Okay.
Wait, you just answered your question. You may not have realized it. You only want to do the ones that are perfect squares.
So what about like 100 times the square root of 12? And then you get the square root of 10 times 12. No, the square root of 12 times 10.
The square root of 12, this is what you just said, right?
Yeah.
Yeah, that's not simplified.
Why?
Because there's a perfect square that can be factored into there. The square root of 4 times the square root of 3 times 10. What's the square root of 4? So 2 square root of 3 times 10, that would be 20. So it's not simplified until there are no longer any perfect squares that can be factored out. Okay? So you kind of answered your question yourself. But good. Okay, back to Z. Now Z is the geometric mean between the adjacent side, which is 40, and the entire hypotenuse. Just like it was 70 here, it's also 70 again. So Z squared then is equal to 2800. Let's simplify that. Perfect squares that become a factor of 2800. $407. 400 is a perfect square. Is it 20? And so Z is. Now that may have been a case. Now let me just show you this. You don't need to write this down. But what if you thought, well, that's 100 times 28. What if you did that? Can you still get the correct answer? Sure. Because that would be 10 times the square root of 28. Now you don't want to stop there. Is there any factors of 28 that's a perfect square? Yeah, 4. Notice we get the same answer. It just gets there a little bit longer. Takes a few more steps. But it's the same. Does that make sense? And so you just keep going when you're factoring. Is there any more perfect squares? And so sometimes it's just a matter of guess and check. And that's why knowing those 11 through 20 can really be helpful. Because you can see what those factors are. And you can divide them in. All right, questions on number 11. Does that make sense? Does that clear it up a little bit? Let's take a look at number 12 while we're here. Okay? I think it's on your next page. So 672, we have a right triangle. Pythagorean theorem is still true. We have an altitude that's drawn in. That means it's perpendicular. And then we've got 9.6 is this segment. We've got 12.8 up here. And we've got Z down here. We also have X and Y. Okay, well, let's solve for Z first. Now, I don't have one for the part of the hypotenuse other than, you remember how we solved for X here? X was the geometric mean between the parts of the hypotenuse. All right, so let's do that down here. All right, Garrett, do that for me. So basically, apply the geometric mean where this were X. We already know X. In this case, it's 9.6, but put it into a proportion. Garrett. Am I clear enough on my question, Garrett, or you want me to go back over it? Let me go back over it. Okay, so the geometric mean of the altitude is the product of the parts of the hypotenuse. See how I put 30 and 40 here? And then I put X here and here. So I want you to do the exact same thing, but don't use these parts. Use these parts. All I want you to do is fill in the proportion with the proper parts. No. Yes. Over 9.6. Because I know that's our unknown in this one. And so we put x here and x there. So 9.6 is going to go here, and what's going to go down there then? Ah, got it. All right, let me pause there. I need you to nod your head if you understand that. Because all we did was the exact same proportion that we did here. We just have different numbers. The unknown, the variable, was the altitude, but not anymore. The variable is the part of the hypotenuse. We good? Now, let's cross multiply. 9.6 times 9.6. Yes, Bo, you have a question?
Yes. How do we know that we're not finding altitude now?
Because of what was given in the triangle. That's the change. It gave us a different...
So we're finding that little space in between, like, z?
Yep, we're finding the value of z. Yep. Okay, so, all right, 9.6. Let's use the calculator. Did you guys know that your calculator has a square button? Not just a square root, but a square button. So like if I turn it sideways, maybe on your calculator, but on your phone, if you can see it, that button that I'm pointing at right there, that's a square button. So I can just hit that. You can't see it. You see that? That's not kind of blurry.
The second one on the second row?
Yeah, you see that? X squared. That makes sense? And so you can just click that, and that gives us 92.16. Is equal to 12.8 z. Maggie, how do I solve for z? Back to algebra 1. By what? You're right. By what? The one that's beside the variable, we have to undo what they're doing. We divide by 12.8. All right, so then z is equal to 92.6 divided by 12.8. And so we have an even number of 7.2. All right. Everyone good? Okay. Micah, we got a blank proportion, and we want to solve for y. All right, so before you do that, all right, in front of everybody, let's go back here and remind ourselves, what did we do with y up here? Y is the side of the big triangle. Is the geometric mean between 30 and 70, which is the adjacent side, which means next to it, and the entire hypotenuse. Got it? Okay, now let's apply it to number 12. So we want to solve for y. So now create the proportion, Micah. You need to see the first one again? Okay. So here's your leg, y, and it's to the adjacent side, 30, to the entire side. So I added 30 plus 40 together. Got it? Back to here. Okay. Yes. Yes. Outstanding, Micah. Very good. He just used what we saw for z and put it there. And so 12.8 plus 7.2 is 20. Now we cross multiply. Y squared is equal to 20 times 12.8. And we get 256. Does that sound familiar? Garrett, do you remember it? I take the square root. Is it a perfect square? And so y then is equal to 16. Yes. You could. Now, in fact, on one of the problems that we're going to do in a little bit, we use Pythagorean theorem. So I don't want to get into it right here. But yes, you could. Okay? And you just mean of this triangle right here, correct, Elise? Yes. She's right. Of that smaller triangle, you could just use Pythagorean theorem. All right. Hope, you're up. I like picking on Hope. Hope, let me help you out on this one up here, and then you can apply it to do what we need to do down here. When we solve for z, it is the geometric mean. So you see where z goes? Between the adjacent side, 40, and the entire hypotenuse, 7. Got it? Same pattern. Got it? Okay, see the head nod? All right, so let's do it. What's the parts? We're doing, in this case it's x. It was z up there, sorry, but it's x. So x is the geometric mean between what? Is 12.8 the side that's adjacent to x? Z is adjacent to x, right? What's the length of z? Good. It's already done for you. Just add them together. 12.8 plus 7.2. And that's equal to 20. Okay, now we cross multiply. X times x is x squared. 20 times 7.2 is 144. Garrett, what's the square root of 144? Garrett's pretty good at these square roots. Mason, you got it? All right, good. Well, we just did number 11, number 12. It'd be a good thing to put those correct answers in your book because we're going to take a quiz on Wednesday. All right, move over to page 672, and let's take a look at number 20. Page 672, number 20. Again, it'd be good to write down these correct answers so you have something to review from to get ready for the quiz. Here's a right triangle. Earlier, Elise said, well, couldn't we just use the Pythagorean theorem? And I was like, yes, we can, and we're going to on this one. ABC, they want us to find, I'll call it X, they want us to find that. Now, they already know on number 20 that BC is equal to 17, so that's the entire thing, the entire hypotenuse, BC, and AC is equal to 15. Okay, well, like I just alluded to, if I look at, let me shade it with my pencil. If I look at the entire triangle, the big one, I can use Pythagorean theorem to solve. Pythagorean theorem is the leg squared plus the leg squared is equal to the hypotenuse squared. Okay? So now when I solve, when I do that, I end up with the hypotenuse squared is 17 squared. One of the legs squared is 15 squared. And the other leg squared, I don't know. We'll just leave that as an unknown, AB. Austin, you see what I did? So this is the general Pythagorean theorem formula. Leg squared plus leg squared is equal to hypotenuse squared. Okay? I applied it to this triangle. Hypotenuse is 17, square it. Leg is 15, square it. My unknown AB is right there. Everyone good? Okay, now let's do some math. AB squared plus 225 is, not plus, is equal to 289. Let's subtract 225. Still AB squared. So AB squared is equal to 64. I'm not going to ask Garrett because we all should know what the square root of 64 is. Now, that doesn't happen very often, that the three sides of a triangle end up to be whole numbers. Look at that. 8, 15, 17. What's that?
Oh, never mind. It's asking for the altitude.
Yeah, we're not there yet. I'm taking a little detour. Okay.
Yeah, but I was thinking, sorry, I thought DC was 8, and I'm like, that's not right.
No, it's not. Okay, so, but this has a specific name, and it's called Pythagorean triples. Now, we actually talk about it more in our next unit, but I'm going to give you a glimpse into the future. 8, 15, 17. And I can just do the math in our head. 17 squared is 289. 15 squared is 225. 8 squared is 64. Okay? Well, let's do another one. Here's another, what we could call, this is the most simple, basic one, a Pythagorean triple. Okay? What's 5 squared? 25. What's 4 squared? What's 3 squared? What's 9 plus 16? Pythagorean triple. Same is true for all their multiples. So if I multiply each one by 2, now watch. What's 10 squared? 100. What's 8 squared? What's 6 squared? What's 36 plus 164? Pythagorean triple. Following? Here's another one. This will be the last one we'll talk about for now. 5, 12, 13. 13 squared. 12 squared. 25 plus 144. Pythagorean triple. Okay? So there's only a few. There's not many what we call Pythagorean triples, but they're good to know, and they're good to have filed away. All right, now back to this. Remember, this didn't solve this. This was just getting at the value of AB to help us solve it. Okay, now, we know that these are similar triangles. Okay, and that was the whole reason we were able to do geometric mean. But since we don't know the parts of these, we're going to go the old-fashioned way. Small triangle to large triangle is in proportion to small triangle to large triangle. What in the world am I talking about? The sides are proportional. Don't forget. That's actually what we covered in 12.3. Okay, the sides are proportional. So, x is part of the small triangle, and it's a leg, to the hypotenuse of the, well, in this case, I'm going to go ahead to the small triangle, or to the corresponding large, doesn't matter, as A is to 17. They are corresponding sides. Okay? Cross multiply, 17 is equal to 120. And then x is equal to 120 divided by 17. Elise, do you have your calculator? Okay, go ahead and take 120 divided by 17 and give me a decimal. Round it to the nearest hundredth. Yes. 7.06. So when we do not have a perfect square and we have a decimal, we're probably going to give it to you, ask you for it into the nearest hundredth. Hi, Corbin. Okay? Similar triangles. Questions? Good? All right, now that's solved for x using Pythagorean theorem and then similar triangles. Was this the only proportion? No, that's not the only proportion. We could have done this. X is to 8, as 15 is to 17.
Well, we have to
Not really. Tomorrow we're going to review. So. All right, so our plan for the week. We're going to review tomorrow. We're going to take a quiz over Module 12 on Wednesday. Thursday and Friday we move on to Trig. Okay. More than likely this will be our last grade for the 9 weeks. This quiz is Wednesday. For those of you that try and play the game of being absent, day that we take a quiz, and you know who you are. Well, that's why we got 2 other days that we can make it up.
So you're telling me I'm just going to miss Wednesday, Thursday, and Friday?
Yes. All right, questions on that? All right, those of you virtual, if you have any questions, send me an email.